Hello everyone, this is Zaza from Entertainment, reminding you that if it's the first time you view our YouTube channel, please make sure that you subscribe. And if you have any comment, please write us on the comment section. That will be asking question if you need some clarity. Okay, in today's session, we'll be dealing with function, of which is the concept that falls under paper 1 of mathematics. Okay, so we are going to start it from the revision that we did from grade 11. It's a grade 10 revision. Sorry, it's a grade 10 revision. Okay, so here, when we talk of a function, we have the line that we call axis of symmetry. Okay, where do we find axis of symmetry? Okay, if a function has a line of symmetry, it means that the function is a mirror image of it about the line of symmetry. In other words, if the function were folded along the line of symmetry, it will duplicate the graph on the other side of the line. Okay, so meaning, okay, here, this is the important part. In other words, if the function were folded along the line of the symmetry, it will duplicate the graph on the other side. Okay, so this thing same as when you are looking at the mirror is a true reflection of who you are. So when you look at the mirror, you see yourself. So the axis of symmetry or the line of symmetry, when you just put this line on that graph, okay, suppose we have this graph. Okay, I'm going to make just this example of ours. Okay, suppose we have this graph. Okay, I'm going to write it here. Okay, making an example of a parabola. Okay, so this is the graph of ours. Okay, this is our graph. Okay, this is the graph. Okay, this is a parabolic function. Okay, when we talk of axis of symmetry, we talk of the line that cuts the graph. If you can take this part, if you are folding a graph, meaning you want to take this line, you want to put this line on top of this one. So it's like you are just pulling this corner, you want to close this graph, meaning this one will go exactly to this one. So will lie exactly on top of this one. So this point here, of which is 0 is to 0 here, we call this one a line of symmetry because this is the line that cuts the graph into two equal halves. So by considering that when you fold along the line of symmetry, it should duplicate the graph in the other side of the line. So how do you fold this one? If you take this line, so you take this line, you want to close this. So meaning this line, when you close it, this one should lie exactly on top of this one. And this one also, this side will lie exactly on top of this one. So it's like a mirror. So this one is the one that acts as a mirror. So this one is looking at so when it's a mirror, that means you're looking at the mirror. So you see something that is exactly same as uh, this one. So if you pull this one, you fold this line because you are folding this graph, taking this one to the other part, meaning this one would lie exactly on top of this one. So if this one lies exactly on top of this one, so we call this point a line of symmetry. We call this line a line of symmetry where the graph is being cut into equal parts. Okay, hope it was clear. Moving forward, okay, so we have the term called asymptote. Okay, and asymptote are imaginary lines that a graph approaches but never touch or cut. So what does that mean? we call a line an asymptote if the graph is approaching that line, but it should never cut that line. So if it doesn't touch it, it doesn't cut it. So we call that line a line of asymptote. Okay, and then we have a domain and a range. Okay, the domain is referred to a possible x values for which the graph is defined. So that means you can say it's the set of element of input that you plug in into the graph for you to get a defined output. So in fact, a domain can be treated as an input and the range is an output. So whenever you plug in a seed, you get an output of that seed. Suppose you want to plant maize, so when you put that seed of maize, you will get an output of what? Of maize. Okay, so it's something like that. Okay, moving forward, we have function and mapping notation. Okay, so if you have something that is written like this, okay, you have y being equal to something. Okay, you have y being equal to something. Sorry. Okay, you have y being equal to something. We call that an equation notation. Let me make an example. Okay, suppose you have this one. Okay, you have y being equal to mx plus c. We call this one an equation. Normally it's an equation of a straight line, but the fact that we have y being equal to something, that one is written in an equation notation. But if it's f at x that is being equated to something, so that one is no longer in an equation notation, but it is in what? It is in what? It is in a function notation. It is in a function notation. Okay. Okay. It's in a function notation. So a mapping notation, it's when you say f at x maps to something. So you see here, if you can look at the notation are not written the same, but they mean the very same thing. You say y is equal to something, or f at x is equal to something, or f at x maps to something. So this thing mean the very same thing, but it's just the notation that is not the same. But the meaning is the same. The only difference is the notation. Okay, let's see. So I was just telling you that this one here it can be written as f at x being equal to the function that depends on x. So you can even say it's x squared plus 3. This is an example. Okay, it's an example. So you see it's a function that depends on x. So here it's just an equation y is equal to something. So it can be written in any form. It's either this one, it's an equation notation. This one is a function notation. This one is a mapping notation. So it's up to you which form do you want to use or which notation do you want to use. But the most popular one is these first two. The first one and the second one. The third one is not popular, especially at the high school level. Okay, moving forward. Okay, so now we'll be specific with the revision. We're revising the parabolic function. Okay, in grade 10, parabola was introduced in this form. So this is the form that a parabola was introduced at a grade 10 level, where A determines the shape of the parabola and Q results in a vertical shift. So when we talk of a vertical shift, it's either something goes down or up. So that one is being represented by this notation of which is Q. Okay, it's Q. Okay, Q is the one that tells us whether the graph shifts certain units up or down, and A is the one that helps us determine the shape of the graph. Okay, how do A help us to determine the shape of the graph? Okay, if the value of A is greater than 0, it's greater than 0, okay, the graph is concave up, meaning it is smiling, shows a happy face. So as the value of A increases, okay, as the value of A increases from 0, the graph is compressed and gets narrower, meaning the increase in the value of A. So starting from 0, keep growing, the graph keep on being narrower. So looking at this graph, okay, let's just look at this graph. So you see here, this line, okay, here, okay, here. So this value of A is less than this value of A, and this one is less than this one, meaning as you keep on increasing the value of A, your graph becomes more and more narrower. Okay, here on the other side, when A is less than 0, so your graph shows a sad face. It's where when you're sad, you see that's how your mouth look like when you're sad, but when you are happy, smiling, you're smiling. This is the smile. This one is the face that shows to be sad. When you're about to cry, that's how you see a child when the child is about to cry, and they'll be like, okay, that means the child is sad. Okay, moving forward. So here, as the value of A decreases, since A is less than 0, you know that A being equal to -1 and A being equal to -2, this one is less than this one. So as A keeps decreasing, the graph becomes compressed or gets narrower also. So this one and this one is the vice versa of this one. Okay, moving forward. Okay, I said to you earlier here, okay, the parabola function is introduced in this form. So we have A and Q, of which A is the one that helps us determine the shape of the parabola graph, while Q helps us find the vertical shift of the graph. So here, a vertical shift is denoted by Q. The value of Q results in a vertical shift, of which is the very same thing that was said previously. So if the value of Q is greater than 0, that means the graph will shift upward. And if the value of Q is less than 0, that shows that your graph will shift downward. So when Q is positive, that means your graph is shifting, because here, this is the mother graph. You see here, it is at the point where Q is equal to 0. So from here, if there is any change in the value of Q, it's either it increases or decreases. If the value of Q becomes positive, meaning your graph shifts from here, move a bit upward, But if the value of q becomes negative, that means your value of the graph of yours will shift a bit downward. Same thing applied even here. No matter whether the graph is sad or happy, but when we talk of the value of q, the value of q, it's, it's the very same way. So if q is greater than 0, that means your graph is shifting q unit upward. If q is less than 0, that means your graph is shifting q unit downward. Okay, moving to this part of domain and range. Okay, we said the domain of a parabola is where x is an element of real numbers, meaning a domain of parabola include every number on a real line. So meaning it is defined everywhere on a real line. Whereas the range of the parabola, it depends. We said that q can be greater than 0 or q can be less than 0. So suppose we have q that is greater than 0. So we start from the value where y is equal to q, because we said y is the vertical shift. So if it's the vertical shift, that means it has nothing to do with what? With x, of which is the horizontal shift. Okay, but this one of a horizontal shift, we are not going to deal with it at this moment because we are still revising work that was done at grade 10, 11, grade 10 levels. It's grade 10 level English. Okay, so the range of a parabola is where y is greater than or equal to 0. And we have two conditions here. You look at the q condition and a condition. So here, when your y is greater than or equal to q, and if a is greater than 0, so this is how you write your domain, your range. In fact, your range, you say y belongs to, you open the square bracket, meaning q is also included. It's also included when you want to find the range. Q is also included up to infinite, meaning your graph here, look at this graph. So here in this scenario, it's where your q is greater than 0 and also your a is greater than 0. So your graph is what? Is smiling. You get my point? Okay, graph is smiling, q is greater than 0, a is greater than, in fact, greater than or equal to 0. So meaning your range starts here. All the possible values or all the possible outcome for y, they end here. All these values of y are not part of the function because the function is this curve written here, this curve or this you can make it a curve, you can say it's a cup or what, but this one, your graph start from infinite up to infinite, but here, this is the minimum value for y. Every value that is less than this one, because this one is q, it's q, because here I said q is equal to 0. If it was here, that means q was going to be positive, which is greater than 0, but all the values of y will end here, the range. So all the values less than this one won't be the part of this function. Here it's where q is greater than or equal to 0, because here you know that y is greater than or equal to q, and q at this point is 0. So the range will be y greater than or equal to 0. But at this point, you see that your graph starts from negative infinity up to a positive infinity. But bear in mind that here, when you talk of domain, negative infinity to positive infinity, but when you talk of range, it's consider all the values that are less than or equal to 0, meaning all the values that are greater than 0 are not part of this function. The only values that are less than 0 and equal to 0 are the only values that are the part of this function when we talk of what? Of a range. A range. Because a range is a possible values of an outcome while the domain is a possible income. Okay. Not income, but input. Sorry, this one is an input, this one is an output. Okay. Let me show you this. Okay, here we have an example. We're supposed to use a table to sketch the graphs. Okay, here we have two graphs. The first graph is this one. It's an f at x is equal to x squared plus 1. And the second graph is this one, of which the g at x being equal to half x squared plus 1. Okay, so here we are required to use a table to sketch this graph. How do you use a table to sketch a graph? Okay, this is what you do. Okay, let me draw my table. Here's my table. Okay, I'm going to do it like this. Okay, here's my table. Yeah, this is my table. Okay, so I have two functions, the function of f and the function of g. Okay, I'll just take a few domain, because the domain we know that start from negative infinity to positive infinity, but I'll just take few values of x. Okay, here I have x is my domain. Okay, let me start from -3. Okay, let me see, -3, -2, -1, 0, 1, 2, 3, 4, and up to 5. Okay, this one is a possible input. Okay, here I have f at x, and here I have g at x. Okay, if you want to find an output for f at x, meaning you take the value of x, you plug it here where you see the value of x, you square it, you add 1, and then you get that value of f at -3. So I'm going to plug a few values. Okay, want to find f at, okay, it's f at x, so it's the output of the function that depends on x, where the value of x is equal to -3. So meaning where you see x, I replace it with what? With -3. You square it, you add 1. Please make sure that you use the correct function, because the function of f at x says that it's f at x that is equal to x squared plus 1. Okay, so meaning when I'm talking of f at -3, because these are the values of x, so these are the all values of x that I decided to use, starting from -3, -2, -1, 0. You can start from negative infinity up to positive infinity, but for you to observe a pattern, you have to restrict yourself. You just take some few numbers. You can start from -3 to 3. You can start from -5 to 5, but just to observe that pattern or shape that comes up whenever you plug the certain values of input. So here, when you say -3 squared, you add 1. So -3 squared gives you 9. 9 plus 1 gives you 10. Meaning here you get 10. Okay, now you want to find f of -2, of which is equal to, it's -2. When you square it and add 1, so -2 squared becomes 4. 4 plus 1 becomes 5. Okay, so when you say minus 1 squared plus 1, you get what? You get 2, because 1 plus 1, you get 2. So 0 squared plus 1, you get 1. 1 squared plus 1, you get 2. 2 squared plus 1, you get 5. 3 squared plus 1, you get 10. 4 squared, of which is 16 plus 1, you get 17. And then when you say 5 squared and then you add 1, 5 squared becomes 25. 25 plus 1 becomes 26. Okay, let us now, because I just decided to plug a few values of inputs to minus 2 and minus 3 so that you see how do I reach to these numbers. Okay, now let me go for g at x. Okay, g at x, we know that g at x is equal to, it's half x squared plus 1. Okay, so let me plug few input starting from minus 3. Okay, so when you say 1 over 2, you plug minus 3, you square it, you add 1. So 3 squared becomes 9. 9 times half, it's 9 over 2. Okay, so becomes 9 over 2 plus 1. And we can write 1 as what? You can write 1 as 2 over 2 if you want to have common denominator. So you have 2 as a common denominator. So we have 9 plus 2. So as the result, you end up having 11 over 2. So here you have 11 over 2. You know that 11 over 2 can be written as, of which is equal to 5.5. So this one is 5.5. So here if you say 5 squared plus 5 squared over 2 plus 1, so it's same as you have 27 over 2. It's 27 over 2, because when you say 5 squared, you have 25. Let me show you. So here if you have say g of minus 2, oh, sorry. Okay, g of minus 2, let's just go for here. So here you have 1 over 2. Yeah, so I made a mistake. 2, you square it, you add 1. So this one becomes 4. 4 over 2, it becomes what? It becomes 2. 2 plus 1 becomes 3. So here it becomes 3, not this number. Sorry. I just use this 5 instead of using minus 2, because the input is this one. You don't use this one as an input, but you use all these values of x. So g at minus 3, g at minus 2, g at minus 1, the very same thing that you did here when you wanted to find the output of this function using these values as input. Okay, let me go ahead. So here, said here, when you say 4 squared, it becomes 4. 2 squared, it becomes 4. 4 divided by 2 becomes 2. 2 plus 1 becomes 3. Let me show you. So here, this one becomes 4. So it is 4 over 2 plus 1, of which is 2 plus 1, of which is equal to 3, meaning here you get 3. Okay, get 3. And then because of space, let's just use the calculator. Just use our calculator. Let's just put this calculator here. Okay. Just put our calculator here. Okay, so this is the calculator of ours. We have 1 over 2, open bracket, because we know the output when the input is minus 1. What if the input now is minus 1? Square it, and then sorry, okay, you plus 1, you add 1. So what do you get? 3 over 2. Okay, meaning here put 3 over 2. 3 over 2 again. Bring back our calculator now. by changing the inputs now, we have to plug 0. But you get 1. So here becomes 1. Okay, when you have 1, because minus 1 squared and 1 squared when the same thing, so that means here it will be 3 over 2. When you plug 2, since minus 2 squared and 2 squared is the very same thing, you get what? Get 3, and then here you get 11 over 2. Just go for 4 now. So just go and change here. Delete, put 4. What do you get? Get 9. Okay, let's go for 9. Yes, 9. When you say where's the calculator, now we're changing, we're putting what? The value of x to be 5. So we end up having 27 over 2. Yeah, 27 over 2. Of which is the value that I wrote here, because I was using an input that was 5 instead of using minus 2. So it should be located here. Okay, so now we know the possible outcomes for f at x and the possible outcome for g at x when the input of these, that's minus 3, minus 2, minus 1, 0, etc. Okay, so now we're required to plot the graph. So when you plot the graph, we are going to have a Cartesian plane. Okay, my graph won't be drawn to scale, but for you, since you'll be given enough space, you have to draw your graph to scale. Okay, here, this is my graph. Okay, this is my graph. Let me check whether do I have positive numbers, negative numbers. No, I don't have negative output. I only have positive output, meaning I have to give myself enough space on the top part. The bottom part, no, I can just leave it like this. Yes. Okay, it's fine when it's like this. Okay, so this is what I have. Okay, this is what I have. This is what I have. Okay, my graph won't be drawn to scale. My graph is not drawn to scale. Okay, but yours should be drawn neat and it should be drawn to scale because you'll be given a graph sheet that has equal squares. So yeah, make sure that your graph is neat. So it's minus 1, it's minus 2, it's minus 3, it's minus 4, it's minus 5. So please make sure that you indicate the arrows that your graph goes from negative infinity to positive infinity. So here at minus 6, minus 7, here to 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's just check here. Okay, we know that the greatest value that you should have should be 26. Let me check. Is it 26? Yeah, it's 26. 26 is the maximum value, so let's just go there. So we have to make sure that the graph has equal space between the terms. So if you say 1, 2, you see you won't reach to 26. If you say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then you put 26 here. Yeah, it's fine. You can count in twos. So 2 here, it's 4 here, it's 6, it's 8, it's 10, it's 12, it's 14, 16, 18, 20, it's 22, 24, and here it's 26. Okay, so when you plot your graph, what is it that you should do? Look at the x, the input and the output. Let us start with this graph. Okay, let's just look at this graph first. Okay, let's just start with this part. Let's just check here. Let's start with f at x. Okay, so you see here, it's a graph of f, and here it's an input. This is an input. Okay, so how do I plot my graph? I look at the value of what? The value of x here. Where's the value of x? Okay, the value of x here is -3. The value of y should be 10. So let me go there, check here. So here, just indicate nyana. Okay, okay, you see here, you go from -3 here to 10. So the point should be here. Should be somewhere here around. Okay. Now -2 to 5. Okay. Go there. So here's -2 goes with 5. So you see that 5 is between 4 and 6. So it should be somewhere around. Okay. So 5 should be somewhere around, you see. So even if you're trying to construct, you see, constructing your dots. So 5 should be somewhere around. Yeah. Okay. Go back to the graph. -1 and 2. Okay. Where's -1? -1 is here and 2 is here. So please make sure that an input is the right one and output is the right one. So it should be here. Yeah, that's where it is. Okay. Moving forward, here you see, when a value of x is 0, the value of y is 1. Okay. So the value of x is 0 here, and the value of 1 should be 1, and 1 is somewhere around here because it's between 0 and 1 and 2. Yeah, 0 and 2, there's 1. So 1 is somewhere around here. Okay. And then when x is 1, the y value is 2. Okay, go back here. Okay, 2 was supposed to be written here. Yeah, 2 is here. Also 2 is here, yeah. And when x is 2, y is what? Is 5. 5 should be somewhere around. When x is 3, y is what? Should be 10. Okay, 10 should be somewhere around. Okay. When x is 4, y is 17. And 17 is somewhere around. Yeah, should be there. Because between 16 and 18. Yeah, it should be here. And then when x is what? Is 5, y is 26. So go from 5, go up to 26. Okay. Normally, if my graph, because what I did here, I did not give them equal values from 0 to the left and from 0 to the right. So if it was -3 to 3, it was going to be given equal values. But here, since I have -3, -2, -1, 0, 1, so yeah. So that's why it seems as if my graph is biased, is more on this side than few here. But when you plotted this graph, now plotting the graph, want to connect the dots, it starts from where? From infinity, and let me construct the dots. These are the dots. Yours should be drawn neat. Constructing the dots. I'm constructing the dots. Okay. and here. Okay, start from negative infinity to positive infinity. So you see the values of x start from negative infinity to positive infinity, but the values of y, it include all the values of y from this one moving upward. But all these values that are less than this one are not part of the function. I'm not sure whether can you guys see what I'm talking about. So all the values that are less than q, because this one is a q, because if you look carefully, if you can fold this line, you take this one, you want to put it exactly on top of this one, even the very same, this one will lie on top of this one. So this one becomes what? A line of symmetry. And go back here. You see here, look carefully. The value of a, because a is the one that is before x squared, the value of a is equal to half, and the value of q is equal to what? Is equal to 1. And if you can pay attention here, this graph has now shifted 1 unit from the center upward since the value of a is greater than 0. So it decided to shift 1 unit upward. It's shifted 1 unit upward, and since a being equal to half, that means a is greater than 0. That's why our graph is happy. So before you plot the graph, make sure that you pay attention here. Okay, you look at the value of a. Is the value of a less than or equal to 0? If your value of a is less than 0, your graph should show sad face. But if your value of a is greater than 0, it should show happy face. So if it does happen that when you are plotting the graph and your graph is showing sad face, but when you look at the the function notation given to you, the value of a is less than 0. The value of a is greater than 0, but your graph is showing sad face. I said sad face is this one. Okay, when the child is frowning, you know that, okay, it's about to cry. This one is sad. And this one is happy, smiling. This one is smiling. So when your graph is smiling, that shows that for this one, it's where a is greater than 0. For this one, it's where a is less than 0. So make sure that when the value of a is greater than 0, your graph should smile. But if the value of a is less than 0, your graph should be sad. So if it does happen that while you were plotting your graph was sad, but the value of a is greater than 0, please don't even bother yourself of submitting that one. Erase it fast, because it shows that you wrote the wrong thing. Okay. So now we are done with the function of f. Now let us use this one of g. We want to plot the one for g now. Okay, let me highlight that one. So here's the g function. Okay. Okay, let me not use the very same color. Let me use this one. Okay. So now this one is for g. Okay. Here we also make sure that every output corresponds to its input. So you plug the value of this one as an input, you get this output. You plug this as an input, you get this as an output. Input, output, input, output, input, output, etc., etc., etc. So okay, let's just start from the value of x, where the value of x is equal to -3. The value of the function at g at x is equal to 5,5, because I said 11 over 2 is equivalent to 5.5. Okay, I'll just go and plot that point. Okay, plotting that point. Okay, here, let's just see. Okay, it's 5.5. 5.5 should be somewhere. Yeah, should be somewhere around. Oh, sorry. Should be somewhere around. Yeah, here. Because you see here, the half part here is 5. Between 4 and 5, you get 5. But between 5 and 6, you get 5.5. So that's why it is a bit upper than this one. So here is the point. So indicating with dotted lines. So it corresponds to this one. Okay. Where x is minus 2, the value of y is 3. Okay. So now we know that 3 is around here. Yeah, 3 is around here. And there's something that I want you guys to observe with this graph of mine and relate it to the notes that you started with. Okay. And then here, when x is equal to minus 1, okay, the value of y is equal to 1.5. Okay, it's minus 1. 1.5 is a bit upper than this one. Should be here. That should be here. 1.5. Should be somewhere around here. Okay. And then let's just check g at x. Okay, when x is 0, y is 1. So it goes here now. Okay. Then they intersect, that where the graph meets, they meet here. Okay, here it's 1.5 also. Here it's at 2. Okay, it's 3, it should be 3 here, it should be around here. 3, and then when it's 3, it should be around here, 5.5. Yes, when it's 4. Okay, let me check from 4. It becomes 9. Go from here. Where's 9? 9 is between 8 and 10. Yeah, so it should be here. Okay, when it's 5, it's 27 over 2. 27 over 2. 26 over 2 is equal to 13. So that means it's 13.5. So here it goes up, it becomes 13.5. So it's between 12 and 14, but it should goes a bit up. Okay, so let me construct my line here. Let me construct my line. Let me use red. Okay, so start from infinity. Let me construct the lines. This one. Constructing my lines. Okay, let me erase a bit. It's just erased everything, but I did not want to erase everything. Just wanted to erase that smaller part. Okay, constructing the dots. There's something that I want you guys to observe here that we did before the session. Okay, look carefully here. This one, this graph, we said this graph is the graph of f at x, and the outside graph is the graph of g at x. Okay, what is it that I said about this? I said that as the value of a increases, the graph becomes more and more narrower, but as the value of a decreases, the graph becomes wider. So if you can look carefully here, the value of a is equal to half. And if you can look here the value of a is equal to what? Is equal to 1. Look carefully. Why am I saying it's 1? Here, the function of f at x is equal to x squared plus 1. So the coefficient of this one is 1 here. So that means the value of A is equal to 1, and 1 is greater than half. So if you can look carefully here, since the value of A is equal to 1 and greater than this one, the graph of yours becomes more and more narrower. As the value of A increases, the graph becomes narrower. But as the value of A decreases, the graph is getting widened. So I think now you can see the difference between these two graphs. As the value of A increases, the graph is getting more and more narrower. And look carefully here, the function of G has the value of Q that is positive 1, and the function of F has the value of Q that is positive 1, meaning all these two graphs shifted 1 unit upward. So from 0 it went 1 unit upward, and the fact that A is greater than 0 here and A is also greater than 0 here, that's why all these two graphs are smiling. None of the two graphs is sad. They are all smiling. Okay, so I think now you see what is it that is required if they say use a table to sketch the graph of given functions. You just write the domain and then you write the range. What is the range? Range is the possible outcome for those functions. So here it's a possible outcome for this function of which is f at x. So how do you find the outcome? So you use input, each and every input, you plug it here, you get an output. Yes, input, output, input, output, input, output. Make sure that you substitute these values of x exactly whenever you see the value of x on that function that depends on that x. I think that explanation is fruitful or will be beneficial to you guys. Okay, moving forward. So you see here I was given two functions of which is f at x and g at x. Now I am given three functions, g at x, f at x, and h at x. Okay, before I even draw at these graphs. Okay, first thing first, what I know about this one is that, okay, this one, I know that the parabola is expressed as, okay, let me say it's y, let me write it in an equation notation. It's y is equal to a x squared plus q. Okay, so here that means the value of a here is equal to 1, meaning a is greater than 0. By default, I know that my graph should be smiling. Okay, and it's plus q. The fact that it's just x squared, that means q on this scenario is equal to 0, meaning the graph did not shift. I know that my graph should turn where the value of y is equal to 0. Okay, moving forward, let me check for this one. So you see here, it's ax squared plus q. I see that, okay, here, that means my value of a is equal to 1, which means my a is greater than 0. By default, the shape, it should smile. And plus q, since q is positive, and now we know that q is greater than 0. What is the value of q? My q is equal to 3, meaning my graph has shifted 3 units upward. Okay, so meaning I know where my graph will turn. Okay, moving forward on the third one, here you see I have h at x being equal to x squared. I know that the coefficient of x squared is what? Is a. So that means a is equal to 1. By default, a is greater than 0. That means my graph should what? Should smile again. But look carefully here. The value of q is now no longer greater than 0. Okay, that means my value of q is less than 0. And my value of q is equal to minus 4, meaning my graph will shift 4 units downward. This one shifted 3 units upward. This one did not shift, meaning it will turn on the origin where the value of y is equal to 0. Okay, so judging from the information that I have here, now I do have an idea on how my graph should look like. But again, they said I should use a table, so I should write my table and then plug in all the possible outcome using the possible input. So it's an input and output, input, output, input, output, just like that. Okay. Let's just draw our table. Okay, let me use my red color to draw the table. Okay, how many functions do I have? Yes, 3 functions and input, which is a domain. So I should give myself 4 spaces. 1, 2, 3, 4. So yeah, 4 is enough. Okay, but at this time I should give myself, should not plug more input. Should just, if I can start from -2 to 2 or -3 to 3, that one will be enough. Okay. This is my table. This is my table. Okay. It's an accent function. Okay. Say -2 here. Say -1 here. 0. And yeah. So yeah, for simplicity, let me avoid having more input. Okay, here it's x, here it's g at x, here it's f at x, and here it is h at x. Okay, x values, let me start from -2, -1, 0, 1, and 2. For simplicity, that's why I decided to choose just few values of x, or few input, or few values of a domain. Yeah. So here, look carefully. Here, if you plug -2 here, you say -2 squared. Please make sure that you open bracket and put -2. -2 should be in bracket. So when you square it, this sign won't be negative, it will be positive, because when you just say -2 and then you say squared, so the answer will be -4 instead of opening bracket and plug -2 in, because when you square it, when you put -2 inside the bracket and square it, the sign changes. But if you decided to plug -2 like this, don't even putting it inside the bracket, that will make the value of the output to be negative. So please make sure that you always put bracket when you see x, open bracket, plug that input, and then square it. So here you put -2, open bracket, -2 squared becomes 4. Open bracket, put -1 squared, you get 1, 0 squared, 0, 1 squared is 1, 2 squared is 4. You see, it's easy on this table because I decided to pick just few possible input. So here, if you say -2 squared, you get what? You get 4. 4 plus 3, get 7. So here 7. So open bracket, plug -1, close bracket, you square it, and then you say +3, you get 4. 0 squared plus 3, you get 3. Or as we say 1 squared plus this one, you get 4. If you say 2 squared plus 3, it's become 2 squared becomes 4. 4 plus 3 becomes 7. Okay. Here, if you say into -2 squared and -4, so it's 4 minus 4 becomes 0. And then if you say -2, 1, open bracket, -1 squared, and then say -3. So it's same as you saying it's 1 minus 4. 1 minus 4 becomes -3. It's -3, and then when you plug 0, 0 squared minus 4 becomes -4. And then when you plug 1 squared minus 4, it becomes -3. And then when you say 2 squared minus 4, you get 0. Let's just square minus 4 gets 0. Okay. Now we have to plot our graph. To plot the graph, at least this one, only 7, that is the biggest value. And look carefully here, we do have negative output, which is -3 and -4. So meaning when we plot the graph, we should accommodate both sides. Yeah, top and the bottom. Okay, let's check. Yeah. Okay, how about, yeah, yes. So you see, I gave myself enough space here even at the bottom because I see that I do have negative values of an output of which is -3 and -4. Previously, I just had only positive output, so that's why I did not bother myself of giving myself space at the bottom. Okay. So yeah, it's -1, it's 1, -2, -3, it's 1, it's 2, and it's 3. Okay. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Okay, -1, -2, -3. Okay, -4 and -5. Alright, it's not necessary here. It's -1, -1, -2, -3, -4. It's -5. Here it's 1, 2, and 3. Oh, here, please make sure that you label it. It becomes X. Yo, my catches in plane was not well labeled. So here it's a positive values of X, positive values of Y. Here it's positive values of X, and here it's negative values of X, and here on the other side it's negative values of Y. So it goes to infinity and also to infinity. So it's -2, it's -3, yeah, it's -4 up to infinity. Here it's 3, it's 4, it's 5. So this arrow shows that it goes up to infinity. So here I say 1, 2, 3, 4, 5, 6, 7, 8 up to infinity. So my intention is with those pointed I drew here or I labeled here. So let me start with this function of which the g at x. So when I put -2 as an input, this is an output of just 4. So I'll have the point that say -2 is to 4. Okay, so this one is -2. Should be in line with 4 when 4 is here. So I leave a dot here. Okay, the other one's -1 and 1. So here it's -1 and 1 is here. So I leave that dot here. And then 0 is to 0, which is the origin. This one says 0 is to 0. And then it's 1 is to 1 again here. Should put 1, 1. 1, 1 is the draw, and the other one 2 is to 4. When the value of x is 2, the value of y is 4. Okay, let me keep it here. So you see, when I'm now sketching my graph, constructing the dots, this is what I'm doing. Stands here and move up. So you see, start from negative infinite when talk of a domain, start from negative infinite to positive infinite. But when you talk of range, this is the smallest value of y that the function has up to infinity. So start from this one and goes up. Okay. And then again, now I want to find this one. Let me label it. This one is a g function, g at x. Let me now go for f at x. So when I see -2 correspond to what? 7. So go, 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 go. Suppose this point is here. Yeah. And then the other one, where is the other one? -1 and 4. Why is -1? Here's -1 and 4. Because here it's -2. Wait, seems as if my graph is not drawn to scale. Oh, okay, yeah, I can see that there's something that is not correct here. Yeah, 2 is here. So it's -2 and is corresponding to 7. So it should be here, somewhere around here. Yeah, it's somewhere around. Now, I'm happy with my point. The other one, when x is -1, y is 4. -1, y is 4. Yeah, it's here. It's here. Other one, when x is 0, please. Here it's -1 and 0, 0. The y value is 3. Yeah. So here, meaning when it will be here. Okay. And then when x is 1, y is 4. And then when x is 2, y is what? Again, 7. Okay. So look carefully here. Let me draw my graph. So I'm constructing the dots. And you can see here that your graph is shifted 3 units upward. But if you can look carefully, the graph is not narrow. It is just, it is curved the very same way as this one. It's just that this one is, it has not shifted. It was like on the bottom where Q is equal to 0, but this one has shifted 3 units upward. So that's where the difference is. But there is no graph that seems to be narrower than the other. No. Since if you can look carefully, they all have the value of A that is equal to 1. So there's no one that is narrower than the other. Okay. Right. Okay. Moving forward. Okay. Now I'm looking at A should X. A should X, where X is -2. The value of Y is what? Is 0. Where X is -2. Meaning it's here. We use which color? We use this one. So it's here. And when x is equal to -1, the value of y is -3. So here it's -1 and -3. Okay. When x is 0, the value of y is -4. So it goes here and there. When x is 1, goes to -3. When x is 2, goes to 0. So when I'm collecting these dots, this is the graph that comes out. This is the graph that I get. Yes, this is the graph that I get. Please forgive me with my graph. My graph are not drawn to scale. Yes, so here. So if you can look carefully here, the only difference is that this one, the value of Q was 0, meaning the graph was at origin. This one, the value of Q was 3, of which means the graph was shifted 3 units upward. This one, the value of Q was -4, meaning the graph was shifted 4 units downward, but it's the very same graph that keeps shifting along the vertical line. I hope using this information I shared with you guys, you will be it will be easy for you to sketch the graph using the table. And that is the only simplest way, or that is the simplest way that you can use to sketch your table. I thank you guys, but I don't want to leave you alone. I'll leave you with something to do. This one is just to try. Use a table sketch to graph. Use the table to sketch the graph of these three functions. Thank you. I'm looking forward to meet you in the other section where we'll be continuing with functions. Thank you.